Hi, and welcome to this video on graphing x-intercepts and the vertex of quadratic functions. Okay, so in this video, we're going to learn how to graph a whole quadratic formula, a quadratic function, and we're going to do that algebraically by finding all of its important points so that we can actually place them on the graph. So before we used transformations, but now we have a transform function, but it may not necessarily be in vertex form, which is how we saw the transformation. In this case, it's going to be in standard form, which is the form f of x is equal to ax squared plus bx plus c. And this is a very common form of quadratic equations, okay? So first off, we're going to learn a few new things, but the other things we've already seen, okay? So axis of symmetry, we're going to learn in this video, and vertex we're going to learn in this video. Y-intercept you've already done, and x-intercepts we did last class, okay? So what we're going to do is talk about axis of symmetry first, okay? The axis of symmetry for a quadratic is x equals negative b over 2a. So let's talk about where that comes from. I'm going to make up a function. So the function that I'm going to make up is going to be f of x is equal to x squared minus 7x plus 10. Okay, x squared minus 7x plus 10. Okay, so where the axis of symmetry comes from is actually from the quadratic formula. So let's go off to the side a little bit. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so in this case, let's rewrite this. We can see that negative b plus or minus the square root of b squared over 4ac is a sum of two fractions. So let's divide it back out into its two fractions. X is equal to negative b over 2a, right? They have the same denominator, plus or minus the square root of b squared minus 4ac, all divided by 2a, right? Because in this case, if you have a sum over a denominator, right, you can separate that into the sum of two separate fractions, right? You guys learned that in middle school. At least hopefully you did. Okay, well, it works the same with the quadratic formula. And so when you separate them out, what you get is this portion here, x equals negative b over 2a, right? So that's where we get our axis of symmetry. So this portion here, b squared minus 4ac, which is the discriminant under the radical, all over 2a, that is actually how far apart our x-intercepts are from the middle of the parabola. So remember, the axis of symmetry, the AOS is what we call it, is the middle of the parabola. So we want to find out where that is for this function here, okay? So the axis of symmetry, first we need our coefficients. A is equal to 1, b is equal to negative 7, and c is equal to 10, just like we did when we were trying to use the quadratic formula, okay? So let's use these coefficients to find out where the middle of the parabola is, our axis of symmetry. So x, in this case, is equal to negative, and b is equal to negative 7, excuse me, is equal to negative 7 over 2 times 1. So in this case, it's going to be 7 over 2, which is 3.5. Okay, so 3.5 is the very middle of our parabola. So in this case, 3.5, let's go 1, 2, 1, 2, 3, and 0.5 would be right smack in the middle. So we know that our vertex is on this line, but we don't exactly know where it is. We know our x-intercepts are going to be somewhere, or we're going to have probably maybe one on each side, or it could be one right on the axis of symmetry, or it could be no x-intercepts, but we have to find that out. So first, let's find the vertex, and then we can see from there probably whether or not we have x-intercepts or not. Okay, so for the vertex, it's the x value of the axis of symmetry. So we just need the y value. This part, x equals negative b over 2a, this portion was already found up here. So we already have that. We know that x is 3.5. So for the vertex, in our case, we know that x is 3.5, so we are looking for f of x, right? So what is f of x equal to? How do we find that? Well, if you guess that we're going to substitute 3.5 in for x to give us the y value for the vertex, you are correct. So when it asks for the vertex, you're not just finding the x value. That's just your axis of symmetry. You actually need to substitute the value in and find the y value. So in this case, f of 3.5 is equal to 3.5 squared minus 7 times 3.5 plus 10. Okay, so I'm going to give you a second to calculate that, so you can pull out your calculator and calculate it. It's probably best to use your TI calculator versus the one on the computer, because that one doesn't calculate very accurately. All right, so go ahead and take a second and calculate that and come back to the video. We'll pause for a second. Okay, so for this value, I got that f of 3.5 was equal to 2.25. Okay, so if you didn't get that, not 2.25, negative 2.25. Excuse me, I forgot my negative there. So if you didn't get that, then you probably want to go back and check how you entered everything into the calculator. So the good thing with the TI is it allows you to enter everything in parentheses and then to square and to give you an exact value so that you can put it all in at one time. So if you have trouble with that, then I can actually help you with that. I can show you how to do that. But so far, if not, then if you're having trouble with it and you don't want to put it all in as one, then you can do each piece. So 3.5 squared, then minus whatever this comes out to be, then whatever, then plus 10. Okay, so you should still end up with negative 2.25. So this means that if f of 3.5 is equal to negative 2.25, then our vertex is the point 3.5 comma negative 2.25. So this is the vertex. So let's go ahead and plot the vertex of our function. So I'm going to use red to plot that vertex. So negative 3.5, it's on this axis of symmetry. Negative 2.25, what I would say would be about there. Okay, you can't necessarily get it exact, but you can get as close as you can. Okay, so the next thing that we want to find is the y-intercept. Okay, the reason I find the y-intercept because it's easy. It's something that I can just immediately go to the equation and get. So I'm going to go up here to the y-intercept, and I can see that it's 10. It's always your c value. So if you have a function in the standard form, f of x equals ax squared plus bx plus c, c is your y-intercept. Why is that? Well, because if you plug in 0 for x squared and you plug in 0 for x in order to find what y is when x is 0, you're going to get the last number left, which is the constant remaining c, because everything else will go to 0. So in this case, 10 is our y-intercept. So it looks like my graph doesn't go all the way up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like my y-intercept is way up here. Okay, it's way up here in the clouds is what I call it. For our case, for your case, maybe your graph is a bit better than mine, or if you knew that before, you could change your axis to a scale of 2, so that we go up 2 every time. But for me, this will work, right? So it's on the y-axis. I'll extend my y-axis up to here, right? My y-intercept is at 10, 0, 10. So that means that since I know that a parabola is symmetric, the y-intercept is how far away from the axis of symmetry. If we look here and count, we have 0.5, 1.5, 2.5, 3.5. Okay, so it's 3.5 away. So if I go 3.5 on the other side, so that would be, since I'm at 3.5, there's 0.5, 1.5, 2.5, 3.5. That lands me at 7. So at 7, 10, I will have a point that matches the same y value as my y-intercept, because the parabola is symmetric, and so the middle of the parabola is passing through 3.5. Okay, so the last thing I need to find are these x-intercepts. Okay, so where in the world does this graph cross the x-axis? I got the middle, I got 2 points on the graph, but you need a total of 5 points when possible. Okay, so let's find those x-intercepts, and that will give me my other 2 points. We learned that you can find the x-intercepts by using the quadratic formula, right? So let's do that. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Well, before I do that, I'm going to pull out this discriminant and make sure that I have x-intercepts before I go try to solve for the x-intercepts, right? So let's use our same coefficients that we got up here. A equals 1, b equals 7, and c equals 10. Okay, so let's do b squared minus 4ac. And so in that case, b was negative 7 squared minus 4, and a in this case was 1, and c was 10. Okay, so this gives me 49 minus 40, which gives me 9, and 9 is greater than 0. So as we learned back in lesson 4.5, that if b is greater than 0, in this case, that tells me that I have 2. So b is greater than 0, it's positive, that means I have 2 real x-intercepts. So I'm going to go back and know that since I have 2 real x-intercepts, I'm going to keep solving. So let's continue. X is equal to negative b, so we already did the discriminant part, so that's going to be negative 7, right? Plus or minus the square root. Since I've already found that this is 9, I'm just going to put it under the square root, all divided by 2 times a, which is 1. So in this case, x is equal to positive 7, because a negative times a negative is positive, plus or minus, let's take the square root of 9 to be 3 over 2. So in this case, x is equal to 7 plus 3 divided by 2, and x is equal to 7 minus 3 divided by 2. So with that, I get x is equal to 10 divided by 2, which is 5, and x is equal to 4 divided by 2, which is 2. So my x-intercepts in this case are the points 5, 0 and 2, 0. Okay, 5, 0 and 2, 0. So I'm going to go back and graph those points, 5, 0 and 2, 0. So 1, 2, 0 will be here, and 1, 2, 3, 4, 5, 0 will be here. So I can see that those are both equidistant from my axis of symmetry, which is here again, right? So let's connect those points. So this one, these will pass through those, and then on the left side it will be this. So what I have is a full parabola. Okay, so I've been able to graph my parabola by knowing a few things. So let's look at what we had to know. We needed to know the axis of symmetry, we needed to know the vertex, we needed to know the y-intercept, we needed to know the x-intercept. Okay, and so for the for the axis of symmetry, we use x equals negative b over 2a. And for the vertex, we took what we found for the axis of symmetry. So we took this and plugged it into the formula f of x. And you can see that go back and see that over here if you had questions, so that we could find the point value of our vertex. Remember that a vertex is a point, so it's never just x equals something, right? Our axis of symmetry was the line x equals 3.5, but the vertex was the point 3.5 comma negative 2.25. Okay, so the vertex is a point. And then we found our y-intercept, which was up here. So our y-intercept was, we found that by plugging in 0 into our x values, and that gave us the value of 0, 10, or our c value. And then we found our x-intercepts using the quadratic formula. First we used the discriminant to determine if we had any, and it told us we did. And so our x-intercepts were 2, 0, and 5, 0. Okay, so go back through this video as many times as you need to in order to figure out and learn how to graph your quadratic equation. Okay, so go through this a couple of times and practice on a clean sheet without your graph. Okay, so find some type of order or process. So if you go through the next few, it actually leads you through it. So if you start, let's graph the quadratic function, you start with this one, then it leads you through. Step 1 is to find your axis of symmetry. Step 2 is to use that axis of symmetry to find the vertex. Step 3 is to find its x-intercept. Find the y-intercept by plugging in 0 for x. And then step 4 is to use the discriminant to see if you have x-intercepts. And then step 5 is to connect all of your points together. Okay, and then analyze the graph to see if it has a minimum or a maximum point. Okay, so before you were learning how to read graphs, but now you're learning how to actually find the data algebraically so that you can actually graph your parabola. Okay, good luck and see you in the next video. If you have any questions, send me an email. All right, thanks.